In the vast expanse of space, where stars silently live and die, two of the universe's most mysterious objects were destined to collide. These were neutron stars, dense remnants of massive stars that once burned brightly but met their end in supernova explosions. What followed was a breathtaking event that had been billions of years in the making, a neutron star collision. Neutron stars are truly extreme. Picture compressing the mass of our sun into a sphere the size of a city, just 20 kilometers across. These remnants are so incredibly dense that a mere teaspoon of their material would weigh billions of tons. And when two neutron stars engage in a deadly cosmic dance, spiraling closer and closer, they unleash some of the most powerful forces known to exist in the universe. The captivating tale of this neutron star collision began over 130 million years ago. In a distant galaxy, two neutron stars born from sibling stars that had exploded long ago found themselves caught in each other's gravitational grip. Over millions of years, they circled around each other, gradually losing energy in the form of gravitational waves, ripples in the very fabric of spacetime, as predicted by Einstein's theory of general relativity. With every orbit, their speed increased, propelling them at a fraction of the speed of light. Then, in a single, awe-inspiring instant, they collided. The impact was unimaginably violent. This monumental convergence gave rise to a colossal explosion called a kilonova, burst of energy, so incredibly intense that it outshone their entire galaxy for a fleeting moment. In this cataclysmic event, heavy elements like gold and platinum were forged, scattering them throughout the vastness of the cosmos. Remarkably, every gold ring or necklace on Earth may trace its origins back to such a majestic neutron star collision. Yet the tale does not conclude with the kilonova alone. In 2017, scientists on Earth, equipped with cutting-edge instruments such as the Laser Interferometer Gravitational Wave Observatory LIGO, detected the gravitational waves emitted by this event. It marked a groundbreaking moment, the first time in human history that we directly witnessed the collision of neutron stars. Alongside the gravitational waves, astronomers captured visible light from the explosion, ushering in a new era in the realm of astronomy. The cosmic dance of these neutron stars, leading ultimately to their fiery demise, not only reshaped our understanding of the universe, but also served as a reminder that even within the depths of space's darkness, the universe thrives with spectacular events that shape the very essence of reality.